Right. Well, this title is Compliance and Regulatory Standards Are Not Incompatible with Modern Development Best Practices, which might seem a little long, but it was actually much longer before. It was also a little bit ruder, so this is good. My name, for those of you who don't know me, my name is Charity. I am the co-founder, CTO of Honeycomb.io. Co-wrote both of those books. I have stickers to decorate the books if you happen to have a hard copy. And I've given a bunch of talks with titles like these. And I was asked to come here and talk about a version of this, but for people who have to deal with regulations. This is the first time I've ever given any kind of security adjacent talk, and it ended up taking a lot longer than I thought it would to write. I have no idea how this is going to go. So my t-shirt says, test and prod or live a lie, and that's what we're doing right now. When I say modern software development best practices, I'm really talking about things like this. I feel like in the past 5-ish years, there's been a huge acceleration in how quickly engineering teams have been able to build, to get their products out to market, to investigate problems when there are problems, and just in general, a lot of the friction that used to be involved with being a software engineer is now kind of optional. And I'll go through each of these briefly, but if you look at the list, again, what they all have in common is they're all about really fast feedback loops. It's about getting your code into production as quickly as possible after you write it, which doesn't necessarily mean users are using it in production, right? It's not always like, I write it, boom, they use it, right? Like, you can have some method to the madness here. But it is about making sure that things don't just like sit out there on branches forever. Because the amount of time between when the engineer is writing the code and when the code is in production and you're trying to understand it, keeping that short enough that you don't have to page projects in and out is critical. It's the most important thing that I think we can spend time on as engineering leaders. This really isn't about being super trendy. These are really the distillation, both technical and social and socio-technical of literally thousands of people years of research and tooling. I feel like as in this industry, we tend to spend so much more time on individual performance than we do on like fine-tuning the socio-technical systems that we operate in, even though the systems that we're operating in have so much more of an impact on how well you can do your job, honestly, than your own knowledge of data structures and algorithms. We'll talk about that in a little bit more in a minute. What I mean by engineers owning their code in production is like the DevOps divide is dead, I hope, right? Systems are getting so complex that you really can't hope to operate the code if you didn't actually write it. And you really can't hope to develop the code. This is the part that often gets smoothed over. You can't hope to develop the code well if you aren't also operating it, if you aren't exposing yourself to the consequences of your own shitty choices. You write it, you're on call for it, you kick off your own deploys, no manual, release checklists, you own it. Practicing observability-driven development, by that I mean you instrument your code as you go, la la la. After you deploy it, you go and look at it in production. Is it doing what you expected it to do? Does anything else look weird? Asking these questions through the lens of the instrumentation that you just wrote is your best chance of ever finding the bugs. Because the cost of finding and fixing those bugs goes up exponentially after that moment. Testing in production, this is spicy, I guess, but everybody tests in production. Every single one of you tests in production. Only some of you admit it. Admitting it, I think, means investing in this. Meaning it's not, we don't do that, la la la. It's like, no, okay. There are some problems that are emergent, that are only ever going to be findable in production. We admit that. So we're going to invest in the tooling and the skill sets to help us do that better, so we can do a better job for our users. It also means looking at production often because you need to know what good looks like. If you only look at production when it's broken, you're not training your gut on like what, didn't close out that app, on what good looks like. Separating deploys from releases using feature flags. Obviously, the key, we're all familiar with continuous delivery, but like the key to really reliable software is shipping smaller diffs much more frequently. And using feature flags is the way that you do this because it lets you like just split out. You can be deploying continuously, to coin a phrase, while also letting your product team like schedule releases and be like, this is when a new feature is going to be launched. This is when it's going to be available. This is when it's going to be accessible. But the good thing is you won't be then debugging it for the first time in production as your users are using it. And continuous delivery, or even better, continuous deployments, means you have no manual gates, no QA, manual QA, no test, We have an ocean of evidence that tells you this does nothing to make software better, and it does a lot to make software worse. And if you haven't read the book, read the book. If you have, CTOs or CFOs who are like, this doesn't make sense to me, make them read the book because there's evidence. This isn't just like randos on Twitter saying it. It makes your software worse to have manual gates. All right, so that was the part I was comfortable with. Now we're getting to the part that I actually had to research. Explain it to me like I'm 5. Compliance. The compliance triad is confidentiality, integrity, availability, AKA you must protect customer data. You must protect your code. That's basically all it says. You have to demonstrate that you have policies, procedures, safeguards in place to protect customer data and evidence that you're following your own procedures. There are various regulations, GDPR, CCPA, HIPAA, et cetera, frameworks, which are different. They get audited, regulations do not. I just learned out in the hallway that there's another fancy one that banks are subject to that I had never heard of. Sounded pretty scary. Didn't have time to update my slides. So we are not in this talk going to fuck around with FedRAMP because I think my security guy was like, FedRAMP is a cauldron of screaming eels and stay away from it. But roughly speaking, like it's okay to have protections beyond what your documented policies say that you're doing, but it's not okay to be not doing what your documented policies say you are doing. And as engineers, like for the last many years in my career, I've been like walking around being all grumpy about, oh, well, we can't do this because of GDPR. Oh, we can't do this because of, SOC 2 or whatever. Turns out, not so much. Not so much. Frameworks are very loose. They're very specific on you must protect your code, you must protect your users. They don't tell you how to do that. However, they may conflict with your own written policies. The ones, thank you. If you have questions afterwards, go ask him. This is not the regulator's fault. It's our fault for translating the regulations into policies and prescriptions that aren't helpful. Which is great because we have way less, it may feel like we don't have a lot of influence over our legal teams and our security teams, but we have way more influence over them than we do over US Congress or the EU. Written policies like, business need, what does that mean? It's up to you. They may also conflict with terms in your customer contracts, like you need to be scanning your code for known vulnerabilities before it goes live. Sometimes these can even conflict with each other, like keep all logs forever and don't log anything. But policies are living documents. They can and should be subject to regular review and reconsideration. Contracts should be negotiated. You should not just be blindly signing whatever gets passed in front of you. Right? Is your security team reviewing contracts is your legal team reviewing them? Are they reviewing them with guidance from you about what is reasonable and what is not? Also, something I learned that was kind of cool is that frameworks can often be used to achieve compliance with regulations. We actually use the SOC 2, or we use the blanking, see, I don't do this for a living. We use the framework one to comply with the regulations one. And I don't remember their names. Compliance standards exist for a reason, and our goal here is not to avoid them or evade them. The problem is that there's so much of this that is actually security theater that drags us down, makes us slower, and makes us less effective and secure. Like, security theater almost never makes you better. But we should always honor the spirit of the control when trying to devise a solution. There are so many examples of ways that that we can actually make things more secure by bringing our engineering brains to the problem and addressing the thing that we're being asked to do instead of just like printing out a bunch of screenshots. So when we're looking for ways to modernize like existing compliance things, it's good to start with places where you can both reap like efficiency gains and also improve security, start with the less risky parts, blah, blah, blah. I was reading, Jez Humble is like the OG, grandfather of all of this stuff. And I was reading this, I was watching this talk that he gave, and this is a paraphrase version of it. He's like, all these people out there are like, we can't have continuous delivery because we're regulated, because we're not building websites. We have too much legacy stuff. And this is my favorite, our people aren't smart enough. None of these are true. None of these are true. None of these forbid you from following modern practices. It's like we play this game of telephone with finance and legal. There's so much cargo culting that's going on when it comes to interpreting these things. None of these are true. This is not only is this a solved problem, it was solved a decade ago. Etsy's been doing this since 2013. The US government, with GovCloud can do this. Amazon deploys 11,000 times a day. So the hard part about this is that every company is a little different. And, what might satisfy security needs, what might be a good enough, business need for us might not be a good enough business need for you because you're handling more financial data than we are, for example. So I feel like we're all kind of stuck in this degraded state because we're fighting these battles individually. And I feel like the only way we get out of it is we start sharing our wins. Like, if there's a blog post out there that says, here's how we solved it and here's how we got it past the regulator, then someone else can take that to their team and be like, look, they did it, we can do it too. So I have just a couple of examples here. Etsy was talking about this in 2013. This is how they did it. They isolated the PCI DSS stuff. They made one team responsible for all the cardholder data. Oof. And the rest of the team could, develop normally. I have a slide here about how branch insurance does it. Are you in the room, Joe? I'm imagining one of, nope. Well, that's too bad. He talks about this a lot on Twitter. They use a lot of serverless. They build off of trunk. They actually do isolate most production engineers from most production data from most engineers. Every developer has their own AWS account, right? Everyone implements this differently. Here's how Honeycomb does it. We have certifications. We are subject to, state regulations. We actually have a cron job that deploys any changes that have been landed in the past hour, every hour. It's so great. I cannot emphasize enough how amazing it is to know that any change you merge is going to be out within an hour. But interpretations will vary based on risk tolerance. One thing that I have learned that is universally true, even that scary banking regulation, is that way too often the paperwork actually matters more than the actual security of the implementation. Our job is to devise solutions that are actually secure without hampering. We have to be a very active part of this conversation, or we're just going to get more and more theater pushed upon us. So when it comes to architecture, this was one of the big objections that Jez was mentioning. And the biggest architectural obstacle to continuous delivery is when you want to ship a single line of code, but you have to deploy everything, all the dependencies. So, loop security in early whenever you're building something new. Make sure that, if you have to deal with the federal government, use FedRAMP or use the GovCloud. Invest heavily in your test suite. If you have to unbundle, who here has had to unbundle a monolith? Woohoo! Fun. Make sure services have their own databases, and bring in security and threat modeling from day one. In general, though, I hear pretty consistently from security people that engineers shouldn't have to be constantly thinking about compliance. If you do, then something was done wrong. Mostly, you should have to think about it when you're setting up something new or when you're gathering a new source of PII. That's when you really want to, bring in security, design things correctly, put in place whatever you can in terms of written policies and procedures, also technical solutions to make sure that, all of your engineering workflows that you want to do can be done safely. On the other hand, engineering performance and productivity, I think should always be on our minds because this is something that is achieved through a lot of small bits of work and it also it dies slowly, right? With 1,000 small cuts. One day it takes you like an hour to run test, build your artifact and deploy to production. And 6 months later, it takes you 6 hours. You didn't do anything terrible. It was just a bunch of tiny little decisions that accumulated over time. And now it takes you 6 hours to build and deploy, right? I feel like this always has to be on our minds, especially if you call yourself some kind of senior engineer, right? Any engineer can write code. Senior engineers, we are supposed to be, the guarders of the flame, right? Are we doing it the right way? Are we doing it in ways that make it easier for everyone to build and be effective? So this is the big lesson that I've learned. Stop blaming regulations. It's really all in the interpretations. And if we want engineering excellence, we have to really partner with security and legal. And this is where I feel like we've been slow to really realize just how much of a competitive advantage it is to build fast, to move fast, to be effective and efficient. This is something we have to fight for it. We have to stand up for ourselves because engineering workflows, it sounds very dry and uninteresting to other parts of the company, but it's at the heart of everything that makes us good at our jobs. All right, now I'm going to segue into a little bit of the argument for how to build high-performing teams. This question of how well does your team perform is one that we often hear, how good are you at engineering? But it is not asking how good you are at engineering. It's asking about your team performance. High-performing teams are ones, the way I define it is, you get to spend most of your time solving new problems, interesting problems that move the business forward. Lower-performing teams spend their time on literally everything else. And if you want to know how high-performing your team is, you can always start with the DORA metrics. How often you deploy, how long does it take for code to go live, how often does it fail, and how long does it take to recover when you do fail. I really always like to add a fifth one, which is how often do you get paged outside of work hours. How often you get paged is interesting, but it's really getting paged outside of work hours that speaks to the unpredictability of your systems, and it burns people out. There's a huge gap between the quote-unquote elite teams and the other 75%. And I want to stress, again, this is not a question of the best engineers versus the rest. This is a question of teams that have good policies and practices versus the rest of us. And it really pays off to be on a high-performing team. Really, the sheer amount of human misery encompassed in this gulf is mind-boggling. And the competitive advantage for teams that improve and iterate on the way that they build together is equally massive. If you're on a high-performing team, you're learning good defaults, good instincts, good best practices, standard ways of doing things. These things always seem obvious once you've learned them or once you're doing them, so we really underestimate just how much effort went into discovering them and developing them in the first place. Elite teams had 208 times more frequent deploys. No, 973 times more frequent deploys. That is not a small difference. And you can basically assume that the engineers were equally talented. As some of the smartest, it is so much harder to work on a team that is deploying software once a month. It is so much harder than it is to work on a team that's deploying continuously. That shit is hard. So if you want to build a high-performing team, what do? Well, obviously, you hire the smartest people from the biggest companies, right? No. No. Setting aside the question of whether you can even evaluate the best engineers, it doesn't really matter. Like, the team is what delivers. You should try to hire good engineers who are great teammates. At Honeycomb, we interview, in our engineering interviews, we have a lot of parts that are about communication, because we've found that, when teams feel like they can talk about what's breaking all the time, they're amazing, right? They get so much better every single month. And we did not chase after just like all of our ex-coworkers. I could talk about that all day. Anyway, great teams are what makes great engineers. Being on a great team is what makes someone a great engineer. All of those ex-Google engineers who are great at distributed systems, they didn't get hired because they were great at distributed systems. They're great at distributed systems because they worked at Google, where they got to work on distributed systems. And every deploy is a chance to learn, right? So on the left, you've got someone who's working on an elite, quote-unquote, elite team, 3,000 deploys per year. And on the left, the poor dude who's working on a team that ships every other month. Who's going to be the better engineer in a couple years? There's no contest. The time sink of firefighting alone will sink you. And what happens with it when an engineer from the elite yellow bubble joins a team in the blue bubble? I feel like a lot of hiring is oriented around the idea that, if you hire the right smart person, then your entire team will get better. But your productivity is going to rise or fall to match that of the team that you join, because if it takes the team a month to ship a line of code, it's going to take you a month to ship a line of code, right? Your ability to ship swiftly and safely has a lot less to do with your individual knowledge of data structures and algorithms, and a lot more to do with the structure that you're participating in. Which is why technical leaders really ought to focus intensely on constructing and optimizing those feedback loops that are at the very heart of the system. What feedback loops? Well, let's talk about CI/CD. I love this quote that shipping is the heartbeat of your company. That came from, I think, from my friends at Intercom, and I love it. Shipping new code should be as boring, as constant, as uneventful, as regular as a heartbeat. And CI/CD is how we get there, right? So when you ask people, do you do CI/CD? They always say yes. Absolutely, we do CI/CD. But do they really? Well, we have a Circle CI account. Most people are doing CI, sorta. But CI is really only the prelude to the main course. The point of CI is to prepare the path for you to do continuous delivery, or even, better yet, continuous deployment. Continuous deployment is the feedback loop that really has the power to transform teams and lives, which means that once you merge your code, it should be automatically deployed by default within an hour or less. If you take no action, it goes live. This is transformational. And I also get that it's not achievable for everyone. But moving towards the goal of getting your code out to production in a short enough time that you can debug it with your intent still fresh in your mind is game-changing. Honestly, if you aren't going to hook CI up to production, why not just run it on your laptop? It's the same difference. I also feel like any CI/CD job that ends without having deployed your code to production is a failed run. It's the beating heart of your company. Fear of deploys is by far the largest source of technical debt in most organizations. Shipping is the heartbeat of your company. The engineering leadership, if we have one job, it's tuning these feedback loops, right, of our socio-technical systems. The speed, the coverage, the cadence. How long does it take you to ship one line of code to production? That's the metric that I think every engineering leader should have, should know, should monitor, should be promoted on the basis of. So I've been talking a lot about crappy feedback loops. Fair question, what does a good feedback loop look like? And I think it looks something like this. You merge a change with anything user visible hidden behind a feature flag, which triggers CI, which gets deployed to production in under an hour. As the Mandalorian would say, this is the way. Feature flags, again, is what allows you to decouple deploys from releases. And you must have tests that you can trust. You must have tests that you can trust. But that precious interval of time between when you write the code and when the code has been deployed, this is everything. Like, keeping it short is the difference between having happy engineers that are solving new problems and, and sad engineers who are solving the same problem over and over. Because at the moment when you finish solving a problem, like, you know everything about what you were trying to build, how you built it, things that you tried that didn't work, what you named it, various variables and functions and everything, the business cause for it. You know all of these things. And how long does that last? I mean, minutes, hours? It certainly doesn't persist if you have to put down that project, pick another one up, and like switch back and forth. Like, you're gonna lose all of that, and you can never get it back again. This is why engineers can find upwards of 80% of all bugs. I did not pull this number out of my ass. Katie McCaffrey did a great talk at Papers We Love New York a few years ago, where she produced science that shows this. But that magical interval when you have all that context in your head and you're looking at it in production, you're asking yourself, is it doing what I want it to do? I just wrote it. And does anything else look weird? Having it be just a few minutes, it lets you hook into the body's own like intrinsic reward systems, like that dopamine hit that you get. If you practice this for a while, you'll get this feeling in your body after you've merged your code that you're not done yet. I'm not done yet until I've looked at it in production, until I've closed that loop. It's amazing. The cost of finding and fixing bugs goes up exponentially as that time elapses. Having a short interval also lets you hold the line against batch deploys. Now, I get that batching a lot of people's changes up into one deploy happens almost everywhere, but it's evil, and it shouldn't. Because if you can deploy one person's changes at a time or one set of diffs at a time, you have software ownership. If you know that your changes are going out within the next hour, you're going to go and look at them. If you're pretty sure that your changes are going to go out at some point in the next day to week, along with 0 to 10 other people's changes, you're never going to look at it. You're never going to close that feedback loop. Which is what leads to this, when I think of it as like the software engineering death spiral, where when that interval starts to get very long between when you write it and when you deploy it, it means that you're going to have larger diffs and a longer turnaround time for code review, which means a lot more time spent paging state in and out of your brain, which means that you're batching up changes and deploying them all at once, which means that you don't really have individual ownership of changes, which means that when something goes wrong, now your entire afternoon is shot while all of you have to put down what you're doing and try to figure out whose code was at fault, which means you spend more and more time waiting on each other, which means you need more people. You need some specialists. Maybe you need a release engineering team. You need more SREs, more people, more coordination costs, which all cost more time. And you can spend your life changing all of the symptoms and pathologies that proceed from this, or you could fix it at the fucking source. So I feel like we've had kind of a lack of motivation when it comes to really putting in the time to do the work to convince our security and legal teams that our time is valuable and our engineering, our engineering practices are meaningful to the bottom line of the business. And I hope that this is motivating, because the idea that security won't let us, this is not true. We can be extremely literal as engineers. I'm sure this is a shock to everyone here. But we are not transcriptionists. We are interpreters. We know what security means better than the legal department does, possibly better than some of the security teams do. Definitely better. Definitely you know more about how to secure your own code than your customers do who are writing these contracts in. We have a responsibility to help them help us be more secure and be more effective at our jobs. There's no law against this. We're all on the same side, and this is very much about better security, not having security. So if I've learned anything from all my conversations with security folks, it's that at the core of it is you document, you do it, you say what you're going to do, you do it, and then you show that you did what you said you were going to do. Also, this is a fun phrase that I learned, compensating controls. which means I'm not doing what you told me to do, but I'm doing what you should have told me to do. Another big thing that's a help to lots of people is you don't actually need to give all engineers like direct access to production. You should give them access to their instrumentation though. If you have commit access and observability, you should be able to debug and understand anything about your software. Good SLOs actually checked a lot of boxes for us too. I don't remember exactly which, but like executive views and monitoring, and like there were 4 or 5 different categories that just having a good SLO gave us. But ultimately, it isn't even just about the economic arguments and the competitive arguments and all of the very good arguments about why we should have higher performing teams. Higher performing teams, this is a quality of life issue, right? Which means I think this is an ethical issue. We spend most of our life at work. We should build high performing teams that are low in toil and high in things like autonomy and mastery and meaning, which begins with keeping your intervals low and your feedback loops tight. I did pull this out of my ass, kind of. How much is your fear of continuous delivery costing you? But I think it's true. Rule of thumb, if it takes X number of engineers to build your software systems with a 15-minute delivery interval, it will take twice as many engineers if you have an interval of hours. If you have an interval of days to get your code out, twice as many more. Weeks, double again. Have you ever seen an app, gone, oh, cool app, what's the team like? They have 800 engineers? What the hell are they all doing? I guarantee you, they do not get their code out very quickly at all, and they spend a lot of time waiting on each other. So the moral of the story is we waste a lot of time. I don't know if you all have seen the Stripe developer report, but 42% of our time we self-report that we just straight up waste. And this is why. So to wrap things up, what would you do with twice as many engineering cycles? What could you build? What problems might you solve? Maybe we can fix our build pipelines and find out. So, in conclusion, are we too busy to improve? And I think I have like 15 minutes left, so questions? Answers? Anybody have something you want to brag about?
I have a question. Go ahead. Oh, you're talking about a fast feedback loop, and you talked about releasing within an hour domain. Do you measure the time that is spent on PR before merging domain as part of that feedback loop as well?
No, not for us. I measure it basically from the point that it's been okayed. Yeah. And we try to keep, the diffs small so that they can be done, same day. But yeah.
If one were hypothetically working for an organization that's kind of at the other end of the spectrum, where would you recommend, what would you recommend as a starting point when dealing with a security compliance organization that is not on board with these principles?
That's a great question. Does anyone here want to answer that? I mean, I can give a stab at it, but I think there are lots of people here who probably know more than me. You?
I'll take a run at it. So I'd say the best thing to do is you want to build a relationship. Because the worst thing you can do is you want to end a war, especially a long-term war. There are times where you have to go to battle to win a small thing, but that should be an action of last resort. So the first thing you want to do is build a relationship and build empathy. Because what you don't understand is they are out there defending you in ways that you don't even know about. And so you have to have empathy there and develop that relationship. But second, you have to help them give empathy for you. And you have to understand why, you have to help them understand why this way is better and why it's better for them. So Charity was spot on when talking about lowering the risk profile. So the smaller the deploy, the smaller the risk. That's not told me this for years. Are you seriously that you're deploying 100 times a day? And I'm like, you want me to show you the deploys? Yes. And they're asked, well, how can you have a security review on every deploy? And I'm like, oh. I was like, this is back to the compensation controls, right? We don't go through a formal security architecture review with the CISO team for every deploy. We follow the security architecture that we all agreed upon, and anything that significantly changes will do that, but we reinforce that we're following the architecture we've already determined through peer reviews. So those are the types of conversations you have to have. It is not an easy, there's no magic push button, and it's, you're in a situation like this, you're looking at a years-long change, unless you have a CEO who's willing to go make radical cultural changes very quickly.
Thank you. That was brilliant. Seriously.
That was amazing, Charity. Yep.
Oh, thank you.